Dear students, in the last class, two important definitions that we have learned. One is that of the average velocity and average acceleration, and the other is instantaneous velocity and instantaneous acceleration. So, what are the formula used for it? The first one is average velocity, which is the ratio of the total displacement to the total time taken. Where what is x1 and x2? x1 is the initial position of the particle at the instant time t1. What is x2? Position of the same particle after time t2. We can even measure instantaneous velocity, velocity of a particle at a particular instant of time, which is given by v bar. We can use v, we use it, v is equal to dx by dt. Similarly, we have average acceleration and average velocity. Average acceleration is the ratio of the total change in the velocity to the total time taken, and instantaneous acceleration is a is equal to dv by dt, that is the rate of change of velocity. So, now we are going to learn something important which is related to the mathematics, but we are going to use that in physics. That is about a concept called differentiation. To understand that, I am going to consider a variable called y, or I can even consider the variable called x like this. Okay. So, here y is equal to, I am going to consider it depends on a factor called t, and it has a power called n, where n is an integer. Okay. Or it can be even a fraction as well. Similarly, here x depends on t with a power n. So, y is one variable, t is another variable. Okay. N is also variable here. Again, x is one variable, t is another variable. So, something like this we are going to consider. Okay. So, it need not be always x and t, it can be y and t, it can be z and t, it can be any two variable. Are you clear with that? Okay. But I am going to restrict to our discussion, so that is why I am going to consider x is equal to t to the power n. When x varies, t also varies here, correct? Now, when x varies with a very small value called dx, x varies with a small value dx, then t also changes. Okay, let that small change be dt. When x changes, t also changes. Let x changes by a very small value dx, and when t changes by a very small value dt, then I can always find what we call dx by dt. What is the value of the ratio of dx by dt? And this we read like this. This is reading of this particular formula is something like this. This is a differentiation of x with respect to t. How do we read that? Differentiation of x with respect to t, or you can even say that it is a variation of x with respect to t, and finding small change with respect to something is called as differentiation. Are you clear? So, now I want to find a dx by dt. Dx by dt. So, then write d by dt as it is, d by dt. What is x? X is a t to the power n. T to the power n. And when you differentiate here x with respect to t, correct? X is nothing but t to the power n. You will get a formula which you have to remember. It's a n into t to the power n minus 1. So, this is a very basic important formula. Are you clear with that? So, when x is equal to t to the power n, keep in mind when x is equal to t to the power n, differentiation of x with respect to t will give you the formula called n into t to the power n minus 1. Okay. Similarly, I can write like this. Imagine if y is equal to t to the power n, then I can measure dy by dt. Okay. Here it was x, right? So that's why we measured dx by dt. Now if it is y, then I can measure dy by dt. What is dy by dt? It is the same thing. Dy by dt is nothing but n into t to the power n minus 1. Okay. Suppose if z is equal to t to the power n, then dz by dt is equal to n into t to the power n minus 1. So it has to be same variable, understood? It cannot be anything else. It has to be t to the power n only. So this formula is valid only for t to the power n, not for any variable or for any function, we call it. Are you clear? Okay. So let's take example based on this. The first one. What if x is equal to t cube? X is equal to t cube now. Are you clear? T to the power n, where n is 3 now. So now when I find dx by dt, look at this, what happens. So dx by dt is equal to, use the formula, n into t to the power n, n minus 1. What is n here when you compare? N is a 3. So n is a 3. T to the power n minus 1, 3 minus 1. How much is that? 3t square. So you have to remember this formulas now directly, okay? So what is the differentiation of t cube? Differentiation of t cube is 3t square. That's how we get it. We don't waste time writing in all the steps like this. So what is the differentiation of t to the power n? N into t to the power n minus 1. What is the differentiation of t cube? It's a 3t square, okay? So those are all important formulas which you have to remember. Okay, so some more. Now what is the differentiation of t square? The second one, where x is equal to t square. Now what is the dx by dt? So dx by dt is equal to x is equal to t square, t to the power n. Now what is the value of n? It's a 2. So use the formula, n into t to the power n minus 1. So n is a 2, t to the power 2 minus 1, which is a 2 to the power minus, t to the power 2 minus 1 is nothing but t only, correct? So it's a 2t. So that's why differentiation of t square is a 2t. Are you following, students? So what is the differentiation of t to the power n? N into t to the power n minus 1. What is the differentiation of t cube? 3t square. What is the differentiation of t square? It's 2t. So let's see some more. What is the differentiation of now t? Okay, so let me write that here. So the third one, what is the differentiation of t? When x is equal to t, what is dx by dt? Dx by dt. So that's d by dt of this x is nothing but t. See, we can use the formula or we can even write directly. What is the dt by dt? Tell me. So dt by dt is nothing but 1, correct? So that's how you get the answer. Let's still use the formula, okay? X is equal to t to the power n. Now what is n? N is 1 here, right? So 1 into t to the power 1 minus 1. 1 minus 1. What is t to the power 1 minus 1? T to the power 0, which is 1. So the answer is 1. Clear? So therefore, 3 important formulas, to be exactly 4 here, not 3. The first one is x is equal to t to the power n. So what is when x is t to the power n, what is the formula? It's dx by dt is n into t to the power n minus 1. When it is a t cube, it's 3t square. When it is a t square, it is a 2t. When it is a t, that's equal to 1. Okay, so we have a few more formulas again which you need to remember, because only then we'll be able to solve numericals based on these. Okay. The next, what if it is a constant? X is equal to a constant. Okay, constant, it can be anything, you know, it can be a number, correct? It can be a fraction also, any constant. Suppose if x is a constant, then what is the differentiation? What is the dx by dt? Dx by dt. Then it's a d by dt of constant. See, when x is a constant, dx is 0, right? There is no change. What do you mean by constant? It is a fixed value, it doesn't change, it doesn't vary. So therefore, dx, there is no change, it is 0. That's why differentiation of a constant is always is equal to 0. Hope you understood that point, student. X is a constant. What do you mean by constant? It doesn't vary. It's a fixed value. So when we are talking about if x is a constant, how can there be a change? There is no change in the value. So dx is 0, no change. What do you mean by dx? Dx is nothing but change in the value of x. And the value of x doesn't change. So dx is 0. So therefore differentiation of a constant is always 0. So another important point or another important formula. Are you clear? Okay, let's see one more. Now x is given as 2t cube, right. So we know what is differentiation of t cube, right? How much? It's a 3t square. Now what is the differentiation of 2t cube? So here 2 we have to multiply now, okay. So therefore differentiation of 2t cube with respect to t is equal to 2, which is again you have to write it as, it doesn't vary, right? It's again a constant into 2 cube. We know differentiation. What is the differentiation of t cube, which is 3t square? That's why the differentiation is 6t square. Very clear? So we are using the differentiation of this formula there in finding the answer. Okay. Okay. Let's try one more. It's a 4t square. X is a 4t square. So therefore the differentiation, what is dx by dt? It's a 4 into differentiation of t square. What is the differentiation of t square? It is a 2t, which is here, right? So what is the answer for that? It's a 8t. Is that clear, students? So let's recall all this once again. Important, because based on this we are going to solve the problem right now. Okay, right. So first formula, what is the differentiation of t to the power n? Differentiation, you have to repeat all these formulas again and again, only then you will be able to remember. Okay, what is the differentiation of t to the power n? N into t to the power n minus 1. What is the differentiation of t cube? 3t square. What is the differentiation of t square? It is a 2t. What is the differentiation of t? It's 1. Correct. What is the differentiation of only a constant? Nothing else, only constant, just like number. Okay, then it's always a 0. What is the differentiation of 2t cube? It's a 2 into differentiation of t cube, which is the 3t square. So multiply, you'll get 6t square. What is the differentiation of 4t square? Differentiation of t square is a 2t, 2 into 4, correct. So 2t into 4, you'll get 4t. So this is how we use the differentiation, and let's use this differentiation in the numericals one by one. Okay, so please see the statement. The displacement of a particle moving along x-axis is given by x is equal, I'm going to write here, x is equal to 18t plus 5t square. This is given. Okay, calculate instantaneous velocity at t is equal to 2 seconds. So first option. What is the formula for instantaneous velocity? Instantaneous velocity is given by v is equal to dx by dt. Correct? You know the formula. V is equal to dx by dt. That is d by dt of x is nothing but here 18t plus 5t square. But writing d by dt of 18t plus 5t square is nothing but differentiating this with respect to time, and we have already learned differentiation formula, correct? Let's use that. 18 into, what is the differentiation of t? It's a 1 plus 5 into, what is the differentiation of t square? That is a 2t. So what we get here is 18 plus 10t. Now that is the value of instantaneous velocity. But what they have asked? They have asked instantaneous velocity at t is equal to 2 seconds. So therefore, at t is equal to 2 seconds, velocity is given by 18 plus 10 into 2. So this is 18 plus 20, which is 38 meter per second, which is the SI unit. See how we used the differentiation formula here in finding what velocity? instantaneous velocity. You know the formula already, correct? Instantaneous velocity is nothing but dx by dt. And dx by dt means what? Differentiating x with respect to time. You understood the application now? How we use a differentiation in finding the instantaneous velocity. Okay? So, most important, repeat all the formulas again and again, only then you will understand all this. Clear? Okay, so I have completed A. Let's go for the option B now. Average velocity between t is equal to 2 seconds and t is equal to 3 seconds. So, average velocity, because average velocity is always found between two time interval t1 and t2. Okay, right. So, first it is given t means a t1. So, t1 is equal to 2 seconds and then t2 is equal to 3 seconds. See, when t1 is a 2 seconds, let us find x1, initial position. To find that x1, I have to substitute here. Okay. So, it is 18 into 2 plus 5 into 2 square, that is 4. This is 36 plus 20, correct? 36 plus 20, that is 56 meter. This is the initial position, x1. Now, when t2 is equal to 3 seconds, we will find x2. That is 18 into 3 plus 5 into 3 square, which is 9. So, 18 3s are 54, correct? Plus 9 5s are 45. Add them, 50, 90, 95, 99 meter. So, we know x1 now, we know x2, we know t1, we know t2. So, therefore, how do you find the average velocity? Average velocity is always x2 minus x1 by t2 minus t1. What is x2? x2 is 99 minus 56 by t2 minus t1, 3 minus 2. So, this will be 43, correct? 50, 90, 96, 99 by 3 minus 2, 1. So, this is 43 meter per second. So, that is the average velocity. Understood, student? So, all these formulas I have revised it already. So, this is the average velocity where we do not use a differentiation. We use a differentiation only when we measure the instantaneous velocity. Now, I want instantaneous acceleration. So, option C. What is the formula for instantaneous acceleration? Instantaneous acceleration is nothing but it is a dv by dt. That is a d by dt of v. What is the value of v? V is here. See, we have found the value of v. V is 18 plus 10t. 18 plus 10 into t. Now, what do you mean by d by dt of 18 plus 10t? Now, nothing but differentiating this with respect to time. See, dv by dt. While measuring the instantaneous velocity and instantaneous acceleration, we use the differentiation formula, not while measuring the average velocity. Okay, right. Differentiate now. Differentiate 18. It's 18 is a number, constant. What is the differentiation of a constant? It's a 0 plus differentiation of 10 again here into differentiation of t is a 1. So, the answer is 10. 10 what? Meter per second square. So, that is the instantaneous acceleration. Okay. So, hope you have understood again the application of the differentiation in finding the instantaneous velocity and instantaneous acceleration. So, we have almost a similar problem. Okay. So, let us try that so that all these things are very clear. So, listen again and then see how we can use the differentiation formula in finding the instantaneous velocity and instantaneous acceleration. Okay. Okay, so let us go for the next question, which is the position of an object moving along x-axis is given by x is equal to a plus bt square. Okay, where a is 8.5, they have given it, a is nothing but 8.5 meter plus b is a 2.5. So, b is also given 2.5 t square. So, this is the value of x now. Okay, x, right. So, first option, what is the velocity at t is equal to 0? So, at t is equal to 0 and t is equal to 2 seconds. What is the velocity at t is equal to 0? T is equal to 0 means instantaneous velocity at that particular time, okay. And then again at t is equal to 2 seconds. So, how do you find the instantaneous velocity? Instantaneous velocity is v is equal, what is the formula? Dx by dt. So, I am talking about the option 1, okay, right. That is a d by dt of x. X is nothing but this 8.5 plus 2.5 t square, correct. So, now what do you mean by d by dt? Differentiating this with respect to dt. First, only a number, constant, differentiation of constant is 0 plus 2.5 into, what is the differentiation of t square? It is a 2t. So, 2.5 into 2 is a 5t. So, we have found the value of v. So, v is nothing but 5t. But they want what is the value of the velocity at t is equal to 0. At t is equal to 0, the value v is also 0. There is one more option. At t is equal to 2 seconds, what is the velocity? Velocity is equal to 5 into t is nothing but 2. So, 5 into 2, 10 meter per second. So, we have found the first option, which is instantaneous velocity. What next? We have to find now the average velocity. Second, what is the average velocity between t is equal to 2 seconds? So, when t1 is at 2 seconds, first find x1. Then, when t2 is equal to 4 seconds, find x2. Why we are finding x1 and x2? Because to find the average velocity formula, correct, to find the average velocity, the formula is v bar is equal to x2 minus x1 by t2 minus t1. That is why we find x1 and x2. So, how to find x1? X is here, so using this, okay, right. So, this is 8.5 plus 2.5 into t square is here, 2 square 4. So, 8.5 plus 2.5 into 4 is 10. So, we will get 18.5 meter. Next, at t2 is equal to 4 seconds, find the value of x2, okay. Again same formula, 8.5 plus 2.5 into the value of 4 here, 4 square, which is 16, okay. So, this is 8.5 plus this is 2.5 into 4 is nothing but 10, 10 into another 4, correct, you will get 40. So, therefore, this product 16 into 2.5 is nothing but 40. 40 plus 8.5 is a 48.5 meter. Now, we will use the average velocity formula. Average velocity is nothing but x2 minus x1 by t2 minus t1. What is the value of x2? x2 is a 48.5 minus 18.5 divided by the value of t2 is a 4 minus 2, 4 minus 2. This difference here 48.5 minus 18.5, correct, is 30. This is 30, correct. Difference here is 30. Divide by 2. 30 by 2 is a 15. We are finding velocity, therefore, the unit is meter per second. So, it is very easy. You just need to practice these problem. So, hope the differentiation and its application is very clear to you all. And we use a differentiation only when while finding the instantaneous velocity and instantaneous acceleration. While finding the average velocity, we do not use the differentiation formula, okay. So, hope the problem that I have explained is very clear to you all. Just practice again once we are done with this particular chapter. So, there will be a test. So, in a few more classes I am going to complete this particular chapter. So, that is why start revising, start reading the problems and then start solving the problem and complete your notes before we start the next test, okay.